define a probability distribution if and only if two conditions are met. First of all, the sum of all the probabilities is going to equal to 1, and 2, each and every probability has to be between and 0 and 1 inclusive. So if we take the distribution of rolling 2 dice and adding up the sum, we know that the possible sums are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the probabilities of those, as we looked at our chart earlier, probability of 2 is 1 out of 36, probability of 3 is 2 out of 36, and so on all the way down. Now, if we look at all the probabilities here, they are all between 0 and 1. And if we add them all up, we will get 36 out of 36. So the sum of the probabilities is 1, and each probability is between 0 and 1. So it is a probability distribution. Now, if we are given a probability distribution, the mean of that probability distribution is defined as the sum of all the x's times the probability of x. And the standard deviation is defined as the square root of the sum of the x squareds minus the probability of x minus the mean squared. So let's go through this calculation quickly here. If I take x times the probability of x, I'm going to get 2 times 1 over 36, 3 times 2 over 36, 4 times 3 over 36, 5 times 4 over 36, 6 times 5, 7 times 6, 8 times 5, 9 times 4, 10 times 3, 11 times 2, 12 times 1. So those are all the x's times the probability of that x in this column. And if I add those up, I am going to get 252 over 36 or 7. So the mean of this probability distribution is 7. Okay? To find the standard deviation now, we have to have another column. We have to have an x squared column, which 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. 36, 49, 64, 81, 100, 121, and 144. That's the x squareds. And then I've got to have a column for the x squareds times the probability of x. That would be this column times this column. In other words, 4 times 1 over 36, 9 times 2 over 36, and so on. I'm going to fill those in. The last one would be 1 over 36 times 144, or 144 over 36. Now, if I take that sum, I'm going to have 1974 over 36, or 54.8. So to find the standard deviation, now that I have done all that, Standard deviation is going to be the sum of the x squareds minus the probability of x, which is 54.8, minus the mean squared, or 7 squared, and I take the square root of that. So I get square root of 54.8 minus 49, which is going to give me 2.42. That's the standard deviation. So I have a mean of 7 and a standard deviation of 2.42 with this probability distribution. What we want to do with that, okay, we remember that normal is defined as the mean plus and minus 2 standard deviations. So in this case, the mean is 7 plus and minus 2 times the standard deviation of 2.42, which is going to give me a top end of 11.8, a bottom end of 2.2. Everything in between there would be considered normal. So in rolling our dice, a sum of 2 or 1 and a 1 would be out of the normal range, and a sum of 12 or 6 and 6 would be out of the normal range. When we talk about the expected value of a situation, we have a definition for the expected value. It's the sum of the x times the probability of x. And as we've just seen, that's the same as the mean of a probability distribution. So the expected value is basically the mean of a probability distribution. So we're going to take an example here where we bet 50 cents on a pick 3 lottery, and if we win, we get $275. So for the first choice in this lottery, there's 10 numbers. Second choice, there's 10 numbers. Third choice, there's 10 numbers. We could repeat the digits. We could have a 111 or a 333. So we have 1,000 possible ways of doing it, and 1 is the winner. So the probability of this is equal to So let's turn this into a probability distribution. X, we're going to win, and if we win, we spent 50 cents, but we get back 275, so our actual profit is 274.50. The 275 minus the 50 cents that we paid. If we lose, we're out 50 cents. Probability of winning is 0.001. Too few zeros over there, 0.001. Probability of losing is 0.999. So if I take the x times the probability of x, I get 0.2745. That's 274.50 times 0.001. Move the decimal over 3 to the left. Lose, I take 50 cents times 0.999, and I get a negative 0.4995. And remember, the expected value, or the mean, is the sum of the x times the probability of x. And if I add those together, I'm going to get a negative 0.225. In other words, the expected value on this lottery, if I bet 50 cents, every time I do that, I can expect to lose 22.5 cents. Not real good odds.